Breaking news from SpaceX. Flight 6 is about to make history with a groundbreaking modification, strategic removal of heat shield tiles. But that's not all. The latest flight timeline reveals an ambitious plan to reignite Starship's engines in space, marking a critical milestone for future lunar and Mars missions. In an unexpected move, SpaceX engineers have deliberately left sections of the thermal protection system exposed around the forward flaps. This bold decision isn't a compromise. It's a calculated strategy to test new catch mechanisms in secondary thermal materials that could revolutionize how we recover these massive spacecraft. The stakes are even higher with the mission's timing, set for late afternoon at Starbase, giving us unprecedented daylight visibility of the descent over the Indian Ocean. While we might miss the spectacular plasma light show typically seen during night re-entries, the trade-off promises crystal-clear footage of crucial landing maneuvers. This is Elon Musk 24 Hours, bringing you the latest developments in humanity's journey to become a multiplanetary species. Let's dive right in. Let's break down the revolutionary changes SpaceX is implementing for Flight 6. Starting with the most controversial decision, the strategic removal of heat shield tiles. The modifications aren't random. They're concentrated around the forward flaps, creating what engineers internally call thermal test zones. These exposed areas will serve as vital data collection points during the vehicle's fiery descent through Earth's atmosphere, with embedded sensors capable of measuring temperatures exceeding 2,000 degrees Celsius. The engineering team has introduced a groundbreaking ablative layer, which Elon Musk claims could double the heat shield's durability. This new composite material, developed in collaboration with NASA's thermal protection experts, combines traditional silica tiles with an advanced carbon fiber matrix. Internal testing shows it can withstand temperatures 30% higher than previous materials while being 40% lighter. This isn't just about making the shield tougher, it's about revolutionizing how we approach spacecraft recovery. Sources within SpaceX suggest the exposed areas might accommodate a sophisticated new catching mechanism, potentially utilizing a state-of-the-art folding system that works in harmony with the chopsticks at the launch tower. This system, dubbed Project Phoenix by the engineering team, features retractable titanium alloy arms designed to deploy during the final descent phase. These arms would provide multiple contact points for the catch mechanism, significantly reducing the structural stress on any single point of the vehicle. The real game changer comes in the flight sequence itself. For the first time, SpaceX will attempt to reignite Starship's Raptor engines in space, a critical test scheduled for T plus 37 minutes and 46 seconds into the mission. This test will utilize a new ignition sequence that accounts for the unique challenges of vacuum conditions. Engineers have modified the Raptor's torch igniter system, implementing redundant spark plugs and enhancing the fuel mixture ratios for more reliable ignition in space. The launch preparation sequence has been meticulously refined through hundreds of simulation runs. At T-minus 1 hour and 15 minutes, the SpaceX flight director will initiate the systems poll, checking over 1,200 individual parameters. Methane fuel loading begins at T-minus 49 minutes and 50 seconds, using a new rapid fill technique that reduces loading time by 15%. The crucial engine chill process starts at T-minus 19 minutes and 40 seconds, utilizing liquid nitrogen at precisely minus 196 degrees Celsius to prevent thermal shock during ignition. The propellant loading system has been upgraded with new cryogenic pumps capable of transferring 3,000 gallons per minute, allowing for faster fueling while maintaining optimal temperature control. These improvements reduce the time the vehicle spends fully fueled on the pad, minimizing boil-off losses and improving overall efficiency. After reaching maximum aerodynamic pressure, max Q, at T plus 1 minute and 2 seconds, registering forces up to 4 Gs, the flight enters its most dynamic phase. The super heavy booster separation occurs at T plus 2 minutes and 39 seconds, utilizing the hot staging technique, a daring maneuver that maintains thrust during separation. This process involves precisely timed ignition of Starship's engines, while the booster is still attached, creating a complex dance of propulsion and aerodynamics. The boost back burn, lasting nearly a minute, demonstrates SpaceX's commitment to full reusability. During this phase, the booster will execute a complex flip maneuver using its grid fins, which have been redesigned with a more aerodynamic profile. The new fins feature an innovative actuator system that provides 50% more control authority during the critical reorientation phase. The mission's timing introduces another layer of complexity. The late afternoon launch window at Starbase means Starship will perform its descent maneuvers in broad daylight over the Indian Ocean. SpaceX has positioned 3 recovery ships equipped with high-resolution tracking cameras and telemetry receivers to capture every moment of the descent. These vessels carry advanced weather radar systems to provide real-time atmospheric data during the landing attempt. One of the most ambitious aspects of Flight 6 is the modified landing approach. SpaceX has increased the angle of attack during descent from 70 degrees to 80 degrees, pushing the flap systems to their limits. This steeper approach allows for more precise control during the final landing phase, but requires the flaps to handle 20% higher aerodynamic loads. Engineers have reinforced the flap actuators with a new hydraulic system capable of generating 50% more torque. The complete flight duration, from liftoff to splashdown, is expected to be approximately 1 hour and 5 minutes. During this time, Starship will reach orbital velocities exceeding 27,000 kilometers per hour, demonstrate in-space engine restart capabilities, and test new thermal protection systems. The vehicle carries over 100 sensors collecting data at 100 times per second, transmitting vital information back to mission control through a network of tracking and data relay satellites. Road closures have been scheduled for November 11th from 7 p.m. to 10 p.m. and November 12th from 10 a.m. to 1 p.m., allowing for the rollout of Booster 13 to the launch site. The launch team will conduct comprehensive static fire tests, including a full-duration burn of all 33 Raptor engines. Each engine undergoes individual testing at McGregor, Texas, before being integrated into the booster, ensuring optimal performance and reliability. Recent wind tunnel testing at NASA's Ames Research Center has provided additional confidence in the modified heat shield configuration. Using a scaled model at Mach 25, engineers have validated the aerodynamic stability of the exposed areas around the forward flaps. Computer simulations running on SpaceX's new supercomputer cluster have processed over 10,000 re-entry scenarios, optimizing the vehicle's trajectory for maximum data collection while maintaining safety margins. Behind the scenes, SpaceX engineers have developed new monitoring systems specifically for this flight. High-speed cameras equipped with thermal imaging capabilities will track the exposed areas during descent, capturing 10,000 frames per second. These cameras use advanced machine learning algorithms to automatically identify and track potential anomalies, providing real-time alerts to the flight control team. The launch pad itself has undergone significant modifications to support this mission. A new water deluge system can deliver 350,000 gallons per minute to suppress acoustic energy during liftoff, protecting both the vehicle and ground equipment. The orbital launch mount features upgraded hold-down clamps with improved release mechanisms, ensuring a clean separation at liftoff while minimizing pad damage. As Flight 6 approaches, NASA has confirmed more encouraging news from the International Space Station. Astronaut Suni Williams and her crew are in perfect health, ready to witness this historic launch from their unique vantage point 250 miles above Earth. Their extended mission until February 2025 might give them front-row seats to several more Starship flights, each building upon the groundbreaking innovations we've discussed today. This latest Starship test isn't just another launch. It's a bold step toward making space travel as routine as air travel. From the revolutionary heat shield modifications to the daring in-space engine restart, every aspect of Flight 6 pushes the boundaries of what's possible in spacecraft design and operation. We'll be providing comprehensive coverage of this historic mission, including exclusive angles of the daylight descent over the Indian Ocean. If you want to stay updated on every development of this groundbreaking flight and future SpaceX innovations, hit that subscribe button and join our growing community on Elon Musk 24 hours. Drop your predictions about the heat shield performance in the comments below. Will the exposed areas perform as expected? Don't forget to share this video with fellow space enthusiasts who appreciate the engineering brilliance behind these technological leaps. This is Elon Musk 24 Hours, where we bring you the future of space exploration, one breakthrough at a time. Until our next update, keep watching the skies.